Having just discussed the law of sines, I think it's about time that we get some practice with some examples. So here we go. We have a triangle ABC and it has some information given to it. And it says solve the triangle. So that means find all missing sides and angles and etc. Complete the triangle, in other words. So first thing to do is, obviously, I like to begin with the picture. So I would make a little sketch here, and I'm not going to assume that it's a right triangle right off the bat. I'm going to just make it kind of obtuse, kind of acute, depending on how you want to look at it. So let's see, angle B is 70. So I'm just going to label these A, B, and then I know that that's 70 degrees. And then this would be angle C. I'm going to call that 48 degrees. Okay, and then it says, let's see, so side C, which would be opposite angle C, is 15. And then we would have angle A that we'd have to find. Um, we'd have to find side length A and side length B. Okay, now before we go on and, just blaze ahead, I want to maybe just pause here and recognize what is the information that we've been given. Okay, we have a side and then two angles. So this is, if you think back to your days of congruency and all that stuff, this would be what we would refer to as angle side criteria, where we're given two angles in succession followed by a side. Okay, so just something for our awareness to help us identify when we need to use law of sines. All right, but anyway, some of this is very quick to find, in particular angle A. That's very easy to find because we know that the angles must sum to 180. So if we take 180 and subtract 70 degrees and 48 degrees, we can find angle A, and that's just going to be 62 degrees. We didn't even have to use a law of sines for that. So yay, part of our work is done. So we have two side lengths to go. All right, and also know that our angles, now that they're completely found, form an acute triangle, so a non-right triangle, so we cannot use the Pythagorean theorem. In its place, we will use law of sines right over here, okay? So let's say I want to find side length A next. All right, so I would have to do a ratio, so I'd have to do sine of 62 degrees over, so sine of angle A over side length A, which is unknown, is equal to, and then I'm just going to use an existing side ratio, so that is already known. So angle C and side C are known. So I'm going to use that as the other one. And again, from this inequality, or from this equality rather, pick two of the three pieces to use. So sine of 48 degrees over 15, and then we can solve, cross multiply. So let's see, we'd get A is equal to, okay, so we'd have 15 sine of 62 degrees, and then we'd have to divide by sine of 48 degrees. Okay, and if you do that, you get that A is approximately 17.8 if you round to one decimal place. Okay, technically, if you're doing sig figs, apparently there's just one sig fig, so you have to call it 20, which to me it doesn't seem quite right. Alas, here we are. Leave it at one decimal place for now. We know side length A now, we have to find side length B. And this one is again using the law of sines. So sine of 70 degrees would correspond to side length B, and then I could use either sine of C over side length C or sine of A over side length A. I prefer to use the one that's given to us all the time, just in case we maybe made a mistake with side length A. This would help us be more accurate. Okay, and again, solving, so cross products, you'd have B would be equal to 15 sine of 70 degrees over sine of 48 degrees. And if you solve this, I got approximately 19. Okay, so there we go. We have all three sides and all three angles. So we're good to go. Okay. Next one, I am not going to do this. I'm going to encourage you to pause the video, try it on your own, and when you're ready to see the solution, resume the video. And here are your answers. again, we're given angle side criteria, so very similar to the previous one. All right, then before we go on, it may not always be possible to make a triangle, right? Remember that all angles have to sum to 180 and they have to obey the triangle inequality. And this just says that the sum of any two sides is greater than the third remaining side. So for instance, if we have sides A, B, C, if we take A plus B, that should be greater than C, and A plus C must be greater than B, and B plus C must be greater than A. All those criteria have to be true simultaneously for the triangle inequality, meaning that it'll give you a triangle, okay? So you can find it, but then there's always this question of, could there be a triangle? Because it said it's not always possible to make a triangle, or could there be multiple triangles? And so with that, I want to caution us, if we're thinking about the different cases where we could use law of sines, you can use law of sines if you're given two sides and a non-included angle. That might be called the side-side angle criteria. Oh, I wanted to highlight. And the only note about this is that this is actually an ambiguous case. You could have one triangle, two triangles, or no triangles. So none, one, or two. And here's kind of a general guideline that you can use to help you figure out when you might have each case. So if you're solving and you get sine of theta or sine of your angle is bigger than 1, that's outside the range of sine, so that's not possible to have. Two triangles would occur if you find an angle and then you calculate its supplementary angle, and that supplementary angle can fit in the triangle that you have based on the given criteria. Okay, we'll see maybe an example of that. Foreshadow. And then one triangle if you find the supplementary angle and that does not fit in the triangle. Okay, so here we're just going to kind of go through some examples quickly. So first, we have a triangle ABC. So let's draw it. We have, let's see. So we have triangle, something like this. I drew it equilateral. Okay, it's probably not going to be. A, B, and B is 31 degrees. Okay, and side B, so opposite would be 3. Side A is 6.2, and C is here. So again, you can see we have the side angle criterion where the angle is not included between the two sides. So side angle. Don't spell it backwards, that's a naughty word. But anyway, if we start solving using law of sines, right, we would say, sine of B, which is 31, corresponds to side length B, and that would be equal to sine of A, right, over 6.2. And I have to start that way because, again, a lot of science is all about corresponding side angle pairs. So I would go through this and I'd say, sine of A is equal to 6.2 sine of 31 over 3, and then if I simplify this is sine of A is approximately, if I'm rounding, it'd be like 1.064, and this is greater than 1, so that automatically means there's no triangle. No triangle, okay? Remember, for sine, we have to be between -1 and 1, okay? So no triangle exists here. Second example, okay, so we have an angle of 30 degrees in the triangle, so I'm going to draw that right now. So this is A, this is 30 degrees, and then its corresponding side is 10, and then this would be maybe side B, and this is 16, and so then we have to go through and complete it. Again, we're given two sides and a non-included angle. So we're still in that side angle criteria. And so again, just kind of going forward as we might, sine of 30 is equal to, or sine 30 over 10 is equal to sine of angle B over 16. Again, that would be the matching pair. So then going forward, we'd solve for sine b. This is equal to 16 sine 30 over 10. And then continuing, you get sine of b is equal to 0.8. And then to solve this, we would do sine inverse and calculating that. So b is equal to sine inverse of 0.8, and this would be approximately 53.1 degrees, okay? And now, let's just go ahead and finish this off. So, on one hand, this would be 53.1, so then we can find, oh, I didn't label vertex C, but vertex C would then be 180, 180 minus 53.1 minus 30, which is equal to 96.9. So great, we have that. C. And then lastly, we would need to find side length C. So sine of 96.9 over side length C is equal to sine of 30 over 10. And then solving, we'd have C is equal to 10 times sine of 96.9 over sine 30. And number crunching, I got that C is approximately, if I'm rounding to one decimal place, 19.9. Okay, so this is one triangle. This one is actually a case where you could have two, because the tip with two triangles is if the first angle that you find, if you look at its supplementary angle, that could fit in the triangle. So kind of the other version, so the second triangle, angle B could be equal to 180 minus 53.1. And this you'd have to check at any time you have the side-side angle criteria. So always check for two triangles. So here, if you do the 180 minus 53.1, you get 126.9. Okay, and how you know it fits is if you can find that third angle. Okay, so if you find B and then you look at angle C, I want to do this in green, angle C, and you say, okay, take 180 minus 126.9 minus 30, and you get something that could actually happen, then that means you could have a triangle. So 180 minus the 126.9 minus 30 just gives you 23.1 degrees. Okay, and if you need a visual of this, again, this is going to be a way obtuse triangle. So we'd have angle B here at 126.9. And then here's angle C at 23.1, very tiny, and then angle A would still be 30. Okay, so you have this obtuse triangle, and the previous one you get an acute triangle. Actually, I lied, that one's also obtuse. It's just less obtuse than the one that we have. So anyway, we have angle B, we have angle C, and then we still have the same side lengths in this other triangle as before. So 10 for A, 16 for B, and then finding angles or side length C, you'd still have to do the law of sines. So sine of 23.1 over side length C is equal to sine of 30 over 10. Again, I prefer to use that known pair, and C would be 10 times sine of 23.1 divided by sine of 30. And if you do this, C is approximately 7.8. Okay, so big takeaway is whenever you have the side-side angle case, be careful, okay? Work through it per normal. If you get sine of an angle is bigger than 1, you're going to get, I mean, you can calculate it, you're going to get a domain error on your calculator. That just means that there's no triangle possible, okay? Otherwise, if you get a value for sine, right, great, go ahead and solve it with that one. But that first angle you find, always consider the supplementary angle. Look at that, try it out and see if, if you're calculate, or if you use that angle, the supplementary angle that is, with the existing angle, if you can make a triangle out of that using, or making sure that everything adds up to 180, then go ahead and find a second triangle, okay? That's really the only way that you're going to know if two triangles exist. But otherwise, these these guidelines here are good ones to pay attention to. So, sine greater than 1, no triangle, and then find the supplementary angle to the one that you find naturally, and if you can make a triangle with that, go ahead and find the second triangle.